Okay, welcome to the second video for week 5. In this we're going to look at the integration of sine and cos. So we've done the derivatives of sine and cos. That's what we looked at the last couple of lessons or the last couple of videos. We know that the derivative of sine x equals cos x and the derivative of cos x equals negative sine x. So as we looked at with polynomials, integration is just that reverse process. Okay, the reverse process of differentiation. So the integral of sine is negative cos x plus the constant, and the integral of cos x is sine x with the constant. So you can remember these separately, or if you just go back to our original value, the integral of cos x is sine x, and the integral of sine x, you can take that negative, is negative cos x. So you can work it out that way, or you can just remember them as separate entities, as long as you remember that they are the reverse process. Now also, if we've got a constant value here, the integral of that, this is just based on the chain rule, becomes negative 1 over k, that's that negative 1 over the constant, times cos kx plus c, and for cos x it becomes 1 over k sine kx plus c. Okay, so all we've done is use these values here with that kx, where we have x here. In the next example we have kx, and just using the chain rule, that would multiply that to get to the original. So again, these are probably things you should remember. Just if you are doing integral and we have a kx, a constant times in the x value, then it's 1 over the k out the front. So a couple of examples to run through. The integral of sine 5x. So this is one of those examples where we've got a constant in our as in the 5x, and that's the rule we're going to use. So it doesn't hurt to write the rule down as you're going to use it. That will start becoming embedded in your mind. But with that rule, we can straight away write negative 1 over 5, because 5 is our constant value, times cos 5x plus the constant c. Now, with integrals, we can always check our answer. Okay, we can always verify our answer. So if we want to verify our answer, we'd take this expression here, negative 1 over 5 cos 5x plus c, and find the derivative of that. We should get 5x. So I'll leave that for an exercise for you to do. Again, it doesn't hurt on your exam to verify that. So our second example, we want to find the integral of 3 cos 12x. The property we looked at when we originally looked at integrals, if we've got a constant here, we can take that constant outside the integral sign. Okay, so that 3 is going to be multiplied by that integral of cos 12x. And just like as we looked at in the previous example, we've got a constant in 12 here, so we're going to use our integral cos x, that should be a k there, so integral of cos kx equals 1 over k sine kx plus the constant. So back to our original expression, we've taken the 3 outside the integral. The integral of cos 12x is 1 over 12 sine 12x plus our constant. Simplify that by multiplying 3 and by 1/12, and we get 1 over 4 sine 12x plus c. Again, check this answer by finding the derivative of it. If the derivative of your answer equals your original expression, then you can be confident that you've done it correctly. Third and final example, here we've got a half sine 2/3 x, and we want to find the y value. So the integral of y equals the integral of dy dx, so y equals the integral of 1/2 sine 2/3 x dx. Again, with that constant 1/2 out the front, we can take that out front at the front of the integral, and so we're just looking at the integral of sine 2 over 3x, or 2/3 x. So using our integral rules, that half, when we do the integral of sine 2/3 x, that becomes 1 over 2/3, because that's our constant here. That should be a times cos 2 over 3x plus c. So when we multiply that together, 1/2 times 1 over 2/3, we get negative 3 over 4 cos 2/3 x plus c. Okay? So again, all it is just taking out that constant value in front of the trig function. So we can do that on our integral, and then finding the integral of the sine 2/3 x. 2/3 is our constant, so the integral is 1 over that constant value times negative cos 2/3 x. And again, you simplify it. Again, verify your answer by forming the derivatives of it. You should be fairly confident with derivatives now of cos and sine, especially in this format. Okay, so you should be able to relatively quickly verify your answer. Now that's about the extent that we look at integrals of sine and cos functions. That's about the extent. We don't go to much more difficult questions. It's just basically using that rule where you got the constant, as we saw earlier. So we'll work through a few of these in class, have a look at the textbook, maybe work through some of the simpler ones yourself, and we'll come back to class and with any problems we have.